So let's do one more example, graphing a rational function. This one is r of x equals x squared plus 3x minus 10 over x squared plus 8x plus 15. So always our first step is going to be to try to factor the numerator and the denominator. So let's see, we'll have x and x plus 5 minus 2, and then x plus 5, x plus 3. So I see I have a pair of matching factors here. This equals 1. So the graph I'm actually going to make is the graph of p of x, that's x minus 2 over x plus 3. Then make a hole when x equals 5, negative 5, sorry. Let me make that look better. Make a hole when x equals negative 5 to make the graph of r. So the two graphs look exactly the same except when x is negative 5. Okay, so we've done the factor numerator denominator. Then find the domain. So x can't be negative 5 or negative 3 because those will make the denominator 0. So then we've written r in lowest terms. That's what p is. And then we need to find the intercepts of the graph. So we're going to find x-intercepts by setting y equals 0. So we're going to say, when does x minus 2 over x plus 3 equal 0? And that happens when x equals 2. So 2, 0 is the x-intercept. And then we want to find y-intercepts by setting x equals 0. So p of 0 equals negative 2/3. So negative 2/3 is the y-coordinate when x is 0, and there's our y-intercept. So those are 2 points that must be on our graph. Okay, then we need to find the vertical asymptote. So we said when x is negative 5, that's a hole. So the only vertical asymptote we're going to get is when x equals negative 3. And then we need to decide if there are any horizontal or slant asymptotes. Well, this function has degree 1 in the numerator and degree 1 in the denominator. So the horizontal asymptote is the ratio of the leading coefficients, or y equals 1. So then we want to know, does the graph of the function, does it ever happen that x minus 2 over x plus 3, does this ever equal 1? So to find a point of intersection, you set the two equations equal to each other and ask if that ever happens. Well, in this case, it will only happen if x minus 2 equals x plus 3, and there's no solution, so no intersection. So what we have found is that you can't cross the horizontal asymptote, or we would have found the place where that happened. Okay, so let's start graphing. So we have, let's come back up here and say, let's see, we have a 2, 0 is the x-intercept. 0, negative 2/3 is the y-intercept. Then I have a vertical asymptote at x equals negative 3. and a horizontal asymptote at y equals 1. Okay, so this graph has fewer sections to worry about. We have from negative infinity to negative 3. Then we have from negative 3 to 0. Then we have from 0 to 2 and 2 to infinity. Those are the only places where anything can change because we have found all the important key points. Okay, so from negative infinity to negative 3, you have to approach the horizontal asymptote and you have to approach the vertical asymptote. So one possibility would be to go like this, but do you see that you can't do that because then you crossed the vertical asymptote and that can't happen. So because you know you must approach the vertical asymptote and you must approach the horizontal asymptote, that gives you only one choice for the shape. Okay, so then from negative 3 to 0, again, we have to approach the vertical asymptote and the horizontal asymptote. So one choice would be to go like this, but we can't cross the x-axis, and we have to go through the y-intercept. So let's rethink this. So I could be approaching the vertical asymptote, go through the y-intercept, go through the x-intercept, and then approach the horizontal asymptote. And that's the only thing that's going to work. Because if I tried to go this way and approach the vertical asymptote and the horizontal asymptote, I would cross the y-axis in a place where I know that doesn't happen. So here would be my graph of the p function, that's the in lowest terms, but then we need to come back here and say, oh yeah, at x equals negative 5, I have a hole. So I need to come down here to x equals negative 5 and say, let's see, what is p of negative 5? So it's going to be negative 7 over negative 2, or 7/2. So at the point negative 5, 7/2, there is a hole in the graph, a puncture. And that's the graph of B. So let me know if you still have questions.